Hello, everybody, and welcome to this live. We're doing physics now. We've just come from doing further maths for those of you who were there. So I hope your paper one went well, actually, for physics. I don't really know how that went for you guys. You can tell me in the chat. But we are going to be doing revision for paper two now. So what exactly do you guys want to do? It's kind of up to you how you want this to play out. Do you want to go through content, or do you want to go through physics and maths due to exam questions? What do you want to do? Do you think I need to do a poll so you guys can ask? There's not too many of you on there, so yeah, of course I could pin the link 100%. Exam questions poll. I will do a poll because we love doing YouTube polls. Okay, give me a second. I will quickly make one because I know people have different strengths and weaknesses, so it depends on that. Give me a second. I'm just making a poll. What would you like to do? And if we go over content, it will either be like chronologically or it will be based on what people want to do. Ooh. Yeah, we'll do a Kahoot at the end. That'll be really fun. Good idea, Yusuf. Okay, I've put the poll on YouTube, so do tell me what you want to do. Let your voices be heard, everybody. Okay, most people, 75% of people are saying exam questions. So let me see, because I don't think it's updated. The poll is on the YouTube community tab. I would link it, but I'm looking at it from my phone. Oh, okay. More people are now saying go over content. So it seems that we're going to go over content. The poll is on the YouTube community tab on her profile. Thank you, Saf, for that. Ooh, I've lost where we're at. Where are we? Okay. It's not pre-recorded. I'm here. I'm alive, guys. We'll do the content and then we'll do some Kahoot and exam questions at the end, okay? Because it seems that most people want to go over content. So let's go over content. We've got in your paper two, you've got forces, you've got waves, and you've got magnetism and electromagnetism. I'll just call it magnetism for now. And then also you've got space for those of you who are doing triple. Oh, thank you. Thank you, Saf. I appreciate that. Yeah, we'll do the content, but we'll try and do it as quick as possible. So now I'm going to do a okay, we'll spend some time doing content and then some time doing we'll do some more lives after. We'll spend some time doing the content and some time doing exam questions. How about that? So I'm going to do another poll asking which of these topics do you want to revise. So please go back to the community tab and I'll ask you guys that. So, okay, so I posted the poll in the community tab, so you can choose which topic you want to revise most, and we'll go on to that. Sorry for making you guys constantly go back to the community tab. I would try and link it. Let's see if I can do that. I would do space, but it's just such a small topic. And yeah. Oh, I thought. Okay, so most people are saying waves right now. We'll be doing other lives later. You can check the timetable to see which lives you want to attend. We'll be doing chemistry and biology later as well. Don't worry. Today is for physics. The live stream is there. Okay, it seems like most people are doing waves, or want to do waves, so let's go and do some waves. Okay. So let me just go to textbook. So there are two types of waves which you should be aware of. You've got longitudinal and you've got transverse. So you can still see this. If you have any questions, or if you want to maybe answer any questions that I ask, do put them in the chat. I would try and explain the hand rule, but it's a bit hard to do that. I actually have a TikTok videos on physics magnetism. If you want to check that out, it explains it. But yes, a bit hard. Thank you, Elle. I'm glad you liked the Further Maths Live. Okay. So, two types, transverse and longitudinal. We'll do a Kahoot after this as well, guys. Trans and longitudinal. Those are the two types of waves. And what are waves? Firstly, waves are effectively how energy is transferred. So it's when a wave happens, particles in the medium, whether a wave is traveling through air, then the air particles of that medium, they oscillate, move up and down, and they transfer energy onto each other. So overall, the particles themselves stay in the same place, but it's the energy that's being transferred. Yeah, it's the same name on TikTok. Now, what have we got? So transverse waves are the typical waves, what you imagine, like ripples, things like that. So the oscillations, key terms here, the oscillations in transverse waves are perpendicular to the direction of energy transfer. For example, in this case, energy is being transferred, let's say, in that direction. Now, perpendicular always means at 90 degrees. So if energy is being transferred over this direction, you can see that at 90 degrees, you've got the oscillations happening, okay? So that's transverse. They're perpendicular. Oscillations are perpendicular to the direction of energy transfer. So what types of transverse waves do you have? Well, these are things like or any electromagnetic wave. Okay. EM stands for electromagnetic wave. So any electromagnetic wave, for example, light. What else do we have? You also have ripples in a tank of water. That's one of your practicals. And you also have any waves on a string. So those are some examples of transverse waves. Okay, and then you've got longitudinal. So with longitudinal waves, the oscillations are parallel to the direction of energy transfer. So longitudinal. So to the direction of energy transfer. For example, if energy is being transferred there, you've got parallel. So they effectively look like lines. Some are more dense, some are less dense. The best example is if you have a string, or not a string, sorry, a spring. So if you have times it's really coiled in areas, and then sometimes it's less coiled, and then sometimes it's really coiled again. And it's almost like these areas of coiledness are moving throughout. That's the best physical representation of it. But longitudinal is often, you don't see it. For example, as people are saying well done in the chat, people are saying sound waves are examples of longitudinal. Yep, that's correct. Also shock waves, for example, seismic waves from earthquakes. Yep, well done, Maxwell. Compressions and rarefactions. Those are the different parts there. So this part here, that is called a rarefaction. And then obviously the parts that are compressed, those are called compressions. So, yep, sound, seismic waves, ultrasound, those are all examples of longitudinal waves. Now, with a wave, there's a bit of different parts that you need to be aware of. So, and this is with transverse waves. So imagine you had a transverse wave graph and you've got one that looks like this. So you need to be aware, or let me make it smaller. You need to be aware of what to call the different parts of the graph. So that the height, the maximum height is called the amplitude. So this is the amplitude of the wave, the height at which it goes. Okay, so amplitude, this is the maximum displacement, the maximum movement of a wave from its undisturbed position. So notice here, the axis acts as the undisturbed position. So when there's no energy being transferred, that is exactly where it's going to be. And then this is the maximum displacement. Max placement, displacement is movement. Remember, it's a vector quantity because you're looking at movement anywhere from the original place. Okay, well done, people saying wavelength and frequency. So wavelength is effectively the length of one complete wave from, if it's from one peak, then it's going to go to another peak, etc. So in this case, it's going to go from here to there. That is a wavelength. Okay, and the wavelength often has a symbol, which is the lambda symbol, like that you'll see in the wave speed equation. Okay, so that is that. And on top, you also have, as people are saying, frequency. So frequency is the number of complete waves that pass a point per second. So it's measured in hertz. So frequency, the number of waves that pass a point per second, and it's measured in hertz. And 1 hertz is effectively one wave passing a point per second. Okay, so the faster the value for the frequency, the faster the number of waves passing per second. Okay, and a period is effectively the time it takes for one full cycle of the wave, for one wavelength. That's what a period is in this case. Okay, now you've got a key equation to remember. I don't know if you're given the equations this year, do let me know. So the equation is for wave speed. So the wave speed is the speed at which energy is being transferred. So, oh, that's a big pen. wave speed, the speed at which energy is being transferred, because that's effectively what waves are, energy being transferred. So wave speed is got the letter V to represent, like as in velocity. So V is equal to frequency of the waves, represented by F, times by the wavelength lambda. Okay, you're given the equation is perfect. But yeah, that's the equation, so you should know how to implement that. Now, you have multiple practicals, or one required practical, talking about the experiment with waves. So the best resource for required practicals is going on to Physics and Maths Tutor. So let me go and find their sheets for that. Physics and Maths Tutor. Okay, so what you do in this practical, you're measuring the frequency, the wavelength, and the speed of the waves, as we already know. This practical is called just waves in this case. So you're measuring frequency, wavelength, and speed by observing water waves in a ripple tank, which is effectively almost this bucket of water. Hello, Shush. I hope you're good as well. And sometimes you can do it on a stretched string as well. So this is a kind of practical which has multiple parts to it. You've got the ripple tank and you've got the string as well. So here's the equipment list. You've got ripple tank, a piece of white paper and card. Now this is important for when you're kind of tracing the waves. Low voltage supply, motor, lamp, stopwatch, meter ruler, vibrator generator, and I post the sheets. Yeah, I can link this if you want. For those of you who wanted to see the practical, it's linked there. Okay, so the method. So you've got the ripple tank part of it, which is here, and then you've got the vibrating string. So you fill the ripple tank, so the water has a depth of approximately 5 millimeters. You place the ripple tank on a top of a piece of white paper or card like shown here. Ripple tank, and then you've got your piece of paper, so it's on a table underneath that. You then place a wooden rod on the surface of the water and attach it to a low voltage power supply. So what that does is by attaching the rod to it, it creates those vibrations. It's really important to do it parallel like that. Oh, you didn't miss just doing waves right now. So you place the wooden bar parallel to the waves so that when you're drawing it, it works out in the correct way. And you need a light source directly above the ripple tank so that when you're drawing it, you can easily copy that out. You're going to view the wave pattern from the side of the tank. Looking through the water, to measure the wavelength, to ruler perpendicular to the wave fronts on the page. So you're kind of just measuring the shadows of the wave from the light. And we talked about wavelength, we talked about all of the things and the different factors you can measure. Now to calculate wave speed, well, you can work out wave frequency, the number of waves that pass a point per second, and you can therefore work out the period and stuff, and you can also work out the wavelength as we saw to work that out as well. So sometimes the overall aim practical is to find the wave speed, and you therefore have to go through those following steps to do that. Now, the second part of the practical is looking at a standing wave on a vibrating string. So you produce a standing wave, i.e. a wave has that classic shape, that transverse shape, and by adjusting the frequency of the generator, so you can alter the number of waves that pass a point per second by using the machine, the generator. The position of the wooden bridge and the tension in the string are also factors that. This live stream is, in this case, we're just going over waves and doing some revision, but on the night before, we'll be covering all of the content through exam questions. So the wavelength of a standing wave is measured across two halves. As you can see here, one half going up, one half going down. Now to measure the frequency, you use a stopwatch to time the wave oscillations over 10 complete cycles. Now if the wave is slow enough, time the point at the center of the half wave length and then start at equilibrium and count every other time the string passes at a complete cycle. I've never really seen them ask too much about this, but this is how it would go. So you've got your weight, your pulley, that acts to make the string taut so that when you're doing the vibrations, it's nice and clear to see. Am I glitching? I'm so sorry if I am. Okay. And then you've got your vibration generator and your power supply. If it becomes hard to understand me, do let me know, and then I'll have to figure something out. Hello, everybody. Is it annoying type of glitching? Should I leave and redo? Rejoin? It's not too bad. Let me leave just in case, and then to make sure this works. Okay, give me a second. Okay, I hope it's a little bit better. So let's continue. So we already spoke about wave speed. We looked at the practical here. Safety precautions, they could ask you about that. I have seen questions in the past about that. So they can ask you, take care working with water and electricity in close proximity, mop up any spillages immediately. Perfect, thank you guys. Don't stand beneath the weight stand, i.e. where the pulleys are. Don't put your feet directly underneath because obviously the weight could damage you. Perfect, that's great. And wear safety goggles when using the oscillating string. Be cautious that the string may snap if it's at high frequency. And also you don't want to put too heavy of weights because then the string could become too taut and then snap. Okay, it's so lovely to see all of you here as well. Okay, so we've looked at the practicals now. Let's look at refraction. This used to be one of my favorite topics because it involved like drawing. So okay, so all waves can undergo three different things. They can be absorbed, they can be transmitted, or they can be reflected. And then let's add another one here, refracted as well, if they're not perfectly reflected. So absorbed is quite self-explanatory. The material has absorbed it. So imagine you've got your material here, and you've got your wave. So if it's absorbed, it doesn't go through it. It's literally absorbed by the material that the wave is trying to cross into. So it's transferring energy from the wave into the material. The material's energy increases. Okay. Now, if it's transmitted, that means the wave carries on traveling through the new material. So transmitting the wave actually leads on to refraction there. But so transmitting looks just like this. It just goes straight through. And then reflected means that it's on the surface of the material, it's redirected, so it faces another direction. Okay, now all of these things depend on the wavelength of the wave and the properties of the materials as well. So ray diagrams are what you can draw for when we're looking at waves that reflect. Okay, so key thing here that you need to remember when drawing your ray diagrams is that the angle of incidence, let me do it in here. Ooh. Your angle of incidence always equals your angle of reflection. So you've got your incident ray and your reflected ray. So imagine this is our surface here, and it has to be a reflective surface if it's a material that undergoes reflection. Now, what happens is you've got your wave, your incident ray. So, key thing here, this is called our incident ray. And you always draw arrows. So in this case, it's going down like that. And then you've got your reflected ray, like that, and you draw your arrow, that going in the opposite direction. Now, what you also have is you have your normal, which is kind of the line, it's a line perpendicular to the surface of the material, i.e. you've got your 90 degree there. And therefore, when we say that the angle of incidence equals the angle of reflection, this angle is equal to that angle there. Okay, so angle of incidence is the angle of the incoming wave and what we call the normal. Let me label that the normal. And then the angle of reflection is the angle between the normal and the reflected ray. Now, this point here is called the point of incidence. Okay, and this material here, the place where it hits that is called a boundary, i.e. the surface of the material that it's been reflected from. It's quite simple. Now, with reflection, it can be specular or it can be diffuse, i.e. the different types of reflection. Specular is when you've got a smooth surface, okay? So specular or diffuse. So specular is when you've got a smooth surface and therefore you've got almost a perfect reflection. Your angle of incidence is going to be exactly the same as your angle of reflection, as the rule always applies. So you've got a smooth surface. Now, with our diffuse reflection, this means that instead it's not in a single direction, the wave is reflected on a rough surface, and therefore the rays are scattered in lots of different directions. So if we're looking at the definitive difference between them, specular is when you've got a smooth surface, and therefore that leads to the reflection in a single direction. And therefore diffuse is when you have a rough surface, a rough boundary, and therefore you've got scattered rays in different direction. Now, remember, this doesn't change the fact that the angle of incidence equals the angle of reflection, okay? It just means that the incident rays are happening at different sides. For example, if we've got a rough surface here, your incident ray might be like that on the first one, but might be hit that side, like a trough in the material on that side. So in that way, the angle of incidence still equals the angle of reflection. However, each of these individual angles are different. So that's the difference between specular and diffuse. Yeah. And you can definitely see that when you look at light rays with different materials. We're now going to move on to before we do that, let's look on the practical, where you're looking at your ray box, shining it through a glass, literally cube, and then seeing what happens. I'm glad you find this live helpful. Okay, so the practical which I'm talking about is when you have your glass box. This is not pre-recorded. This is live. So you've got your glass box and you've got your paper underneath. So normally it's like A3 paper. Okay, and the thing that's shining the light at it. So your light or your ray box. So imagine we've got a ray box here. I'm going to try to look a bit different. And then we've got it shining the ray. So imagine it's shining the ray at the box. You've got your refracted ray here. So the boundaries between different substances refract light by different amounts. You can investigate this by looking at how much light is refracted when it passes from air into different materials. So you can use a transparent block of material, i.e. a glass block. Then you can look at materials that are only slightly translucent, etc. This is for triple. I'm not too sure if it's applicable for combined. I'm not too aware of that. So you've got your transparent rectangular glass block on the piece of paper. You then want to trace around it. Make sure you trace around it so you've got your shape drawn out on your piece of paper. Okay, and then what you do is you to shine a ray of light to the middle of the side of one of the blocks. Okay, and then what you do is you trace the incident ray. So you draw with pencil your incident ray and you draw your arrow and everything. And you draw your normal as well so you can measure the angle of incidence. And then what you do is you follow the path in the block. So you now know where it comes out because you can see this part here. So you then trace that refracted ray and draw the perpendicular to that to find that angle of refraction. And then you've got your start point. You've got your start point and you can connect those two together. I'm sorry that this is cutting out. This is slightly annoying, but I'll try and fix it soon. You then trace that together and connect those 2 points once you lift the glass block up. And then you can talk about how this angle of incidence is different to the angle of refraction. Okay, let me fix the cutting out. Give me a second. Okay, hopefully this is a little bit better. And yep, do keep telling me if it starts cutting out. I'll just leave and then rejoin. Okay, so that is that practical there. And what you can rectangular block made of different material. And key thing to focus on as well is you can also draw this angle here and see whether this angle equals that angle. Is it still cutting? Oh wow, that's really annoying. Maybe because a lot of people are using the internet right now. Um, Is it better? Yeah, I think it's an internet issue. You can still hear what I'm saying. Okay, that's fine. Yeah. We'll do a Kahoot soon as well, because once we get through this topic. My Wi-Fi's off, so. Okay, so that is that practical. We're now going to look at electromagnetic waves and a bit more about refraction, explaining what we saw, and then the different types of waves. It's so nice to have so many of you here as well, because last year I was doing these lives, but there would be one person turning up, so this is a better outcome. I hope your revision through your half term is going well as well. I know it's quite difficult to revise. You feel like you've already done so many exams, you just have to keep going. But don't worry, A-levels are a little bit easier in that way when you get there. Okay, so electromagnetic waves and refraction. So electromagnetic waves, you've got to view it as a continuous spectrum. It's not just one thing there, one thing there, one thing there. It's a continuous spectrum. So, and as I said before, all electromagnetic waves are transverse waves, so they look like that. Now, as you go across the spectrum for electromagnetic waves, what happens is they have different properties. So what happens is their wavelength gets smaller and smaller and smaller, and their frequency gets greater and greater and greater. I sympathize with you guys. I know it's hard to revise during half term, but don't worry. Just picture that summer when you're done with your exams. Okay, so as you go across the electromagnetic spectrum, what happens is as I said, your wavelength gets smaller and smaller and smaller, and your frequency gets bigger and bigger and bigger. So, what do we have? Well, you might have different ways of remembering the different types of electromagnetic waves. So you've got radio waves, you've got microwaves, you've got infrared waves, i.e. light, you've got visible light, you've got ultraviolet, you've got X-rays. Guys, you should put in the chat which ways you remember this from, like which mnemonics, if you use any. I always find it funny to read them. Okay, so radio, micro, infra, visible, ultraviolet, X-rays, and gamma rays. So, as I said, frequencies get larger as you go across, and wavelengths get smaller. And because of their different properties, they have different uses and different purposes, which we'll look at soon. The song, there is a song. I didn't know that there's a song. But yes, so going through the different uses of them. So we've got radio waves. Now, radio waves are made of oscillating waves, obviously, and these are used for radio. So alternating currents made of oscillating charges. As the charges oscillate, they produce oscillating electric and magnetic fields. Transmitted radio waves reach receivers. The radio waves are absorbed. Okay, so you've got transmitters and receivers. So I don't think you need to know how fiber optic cables work, but do correct me if I'm wrong. Okay, so radio waves, they are used for transmitting different pieces of material and different energies. So you've got your electrons oscillating and they produce these waves. So transmitters. And you've got your receivers. So because they have a very large wavelength, it makes them really good for transmitting data and radio waves and transferring that energy. And then so once you've got those transmitters and receivers, what they then do is they then show those oscillations. And that's how carrying lots of information. Their wavelength is really big, so it's 10 centimeters, of up to 10 centimeters. Now, long wave radio can be transmitted from London and will go halfway across the world, so that's why it's used, as we said, for radio waves. Now, you've also got short wave radio signals as well, which are slightly less useful, longer than 10 centimeters, sorry, not smaller, so longer than 10 centimeters. Okay, now Bluetooth is an example of radio waves, short wave radio signals. They are used to send data over short distances between different devices. You've also got medium wave signals as well, which reflect from different levels of the atmosphere to different satellites at different times of the day. So that is radio waves. Now looking at microwaves, which are used by satellites. So microwaves are used for communication via satellites. TV signals, phones, Google Maps, you've got like the TomTom on your cars if you still have those, and anything like that. So they use microwaves, and they pass easily through penetrative. Now, when it's picked up by the respective satellite dish that's orbiting around the Earth, the satellite transmits a signal back to Earth in a different direction. So there is a slight time delay, but it works. Now you also have microwave ovens, which are interesting, and yes, well, and remotes as well. So in microwave ovens, the microwaves need to be absorbed by water molecules in food. So they use a different wavelength to those compared to satellites. Okay, now looking at infrared. So infrared is all about looking at heat. So it's given out by hot objects. And the hotter the object, the more infrared radiation you're releasing. Everything releases infrared radiation. Right now, you're sitting wherever you are in your room or wherever you could be, and you're releasing infrared radiation. Now, if you're hotter, if you feel really warm right now, then you're releasing more than you normally would. Now, you can use infrared cameras, detecting and monitoring temperature. There's a camera that can monitor the temperature, which is quite interesting. And obviously, the hotter it is, the brighter it appears on the infrared cameras. Now, absorbing infrared radiation causes objects to get hotter as well. So food can be cooked using IR radiation. You also use infrared in electric heaters. As well. And a long piece of wire, and that heats up when current flows through it. And the wire emits a lot of infrared radiation, and therefore it's quite a lot of efficiency because most of that energy you want to heat up. So it's not like there's wasted energy. Sometimes there's sound which acts as that wasted energy. Okay, now visible light, as somebody mentioned earlier, that is example fiber optic cables. So they carry data and they are much stronger compared to just a classic wired copper wire. And what they do is they're much better because they're faster over long distances and they work for a long period of time. And again, they use the principles of reflection to transmit data. Okay, then you've got ultraviolet. So ultraviolet radiation, these are the things that give you suntan. So I don't know if any of you guys have ever gone doing sun tanning. No worries, Tris. If any of you have done sun tanning, I don't know if you have. Don't though, because it could lead to cancer. So try not to or avoid it as much as possible. You've also got fluorescent light bulbs, which generate UV radiation, and they are energy efficient. They tend to be used. And it's also produced by the sun, hence the name suntan. Okay, looking at X-rays now and gamma rays. So X-rays are used by radiographers in hospitals, and also gamma rays. They're both used for taking almost photographs of people, taking pictures of people's bones and literally doing X-ray photographs. So X-rays pass easily through the flesh, but not so easily through denser material like bones or metal. And that's why it kind of reflects where your bones are, and that's why it makes that picture of your skeleton. That's how it works. Now, radiographers use X rays and gamma rays to also treat people with cancer. Well done, Ishan, that's correct. Sterilizing medical equipment, gamma rays can be used for that as well. And it can also be used for radiotherapy. High doses of these rays kill all living cells, so they are directed towards the cancer cells because you don't want to kill any healthy cells. And on top of that, it's important to note that X-rays and gamma rays can be harmful, and that's why you need to be really, really careful. We are going to do biology. I might try and fit it into the schedule. Good question. Okay, and those are the different uses of all of those electromagnetic waves. Now, you need to be aware of the dangers of electromagnetic waves. So, when electromagnetic waves enters living tissue, it's harmless, but sometimes it could be harmful, as I spoke about with UV and suntan beds. So low frequency waves don't transfer much energy, but if you've got a high frequency wave, i.e., the further you go across the electromagnetic spectrum, the more dangerous it could be. Why is it more dangerous? Because the frequency is higher. Now, if the frequency gets higher, that means that more energy is being transferred per second. And if more energy is being transferred, it could prove to be too dangerous sometimes. Okay, and X-rays, therefore gamma rays, because they transfer a lot of energy, they could lead to a lot of sun damage. Now, UV radiation that damages surface cells, which could lead to sunburn, skin to age prematurely, some more serious effects like blindness and increased risk of skin cancer as well. You can measure the risk using the radiation dose in sieverts, if you're aware of that. So whilst UV radiation, X-rays, gamma rays are all harmful, they are very useful. So you can measure the risk using sieverts. Now, I don't know if you guys ever knew this, but did you know that bananas are quite radioactive? And if you were to eat, like, I think it was 2,000 bananas, you would die because of radiation overdose. So sieverts helps you measure effectively the risk of all of the radiation emitted, because a lot of things emit radiation, so how much can actually be dangerous. So it's effectively looking at the risk of harm from the body being exposed to radiation. Okay, so the higher the sieverts, the higher the possible exposure, the hazards of being exposed to it. So it's not a measure of the total amount of radiation being absorbed. Instead, it's how much harm that humans are affected by it. Okay. Um, Now let's see what else we've got. So we've got to look at lenses. We've got to look at images and ray diagrams, concave lenses, visible light, etc. Goodbye, Maxwell. Thank you for coming to both lives. So we've got a bit of content to go over. So would you want to go over the content, or do you want to do a Kahoot? Because it's been about an hour. So If you want to do Kahoot, put 1 in the chat. And if you want to go over the content, put 2. Just once, please, so I can see what everybody wants to do. Okay, everybody has literally said 1. Does nobody want to go through content? That's fine. Okay. That's absolutely fine. Let's go over. Okay. Let's see what we can do. Okay, I know some people want to go over content, but it seems most people want to go over a Kahoot. So let's do that. I'm sorry for those of you who want. The night before the exam, we'll be going over all of the content in one live, so you can rely on that. This was just to help you guys, spur you on with your revision. Okay, I'm going to find a Kahoot and let's see what topic. So I'll choose either magnetism, because we've gone over everything else. Well, thank you, Yusuf. I enjoy helping you guys. I remember when I was doing my GCSEs, it was quite boring revising, so I think it makes it a little bit fun at least. No worries, guys. We need to do something for the last exams. Like, once we've done all of the exams, we should do some sort of celebration or something. Okay. Let me find a physics-related Kahoot now. About forces or something. And then we may have to do multiple because I think there's 40 people here. Actually, 1 would probably be sufficient. Yeah, we should do a celebration live. Yeah, we should do like a. I know Google Meet was quite catastrophic last time, but we should do a Google Meet because it's actually kind of fun hearing you guys. I know some of you would be kind of fun. You should do that, yeah. That's a good idea. A big Kahoot. Yeah, maybe I'll have enough money to buy the actual Kahoot where more than like 20 people can join. So, okay, I'll put the link in the chat so you guys can join. And if you don't join that one, don't worry, I'll make another one for you to join. Okay, it's getting full now. So once it reaches 20, some people might not be able to join. and then I'll give you the other one to join. Okay, it seems like, is that it? Okay, if you are unable to join the new one here, but I'm going to start the game for you guys. Let's go. Let's see who can win. Forces. Okay, let's see who's at the top here. We've got me at the top first, Chidima Wizard fourth, and IPV fifth. Okay, you can all change. Okay, Chidima's at the top there. Me is second. No Pancake GSCE is third. Okay. Let's see if that'll change. Game. I'll start that game soon if nobody else joins. Okay, Chidima's still there. Well done. This live started at 7. But Jude, make sure you join the... Oh, a lot of people want to join now. Okay. I'm going to start that game. If you're unable to join that game, then join this one instead. But yep, second game is starting. We're doing all of paper 2 revision. Do the topics that we didn't cover. Yeah, Jude, you're late, unfortunately. It's fine. Chidima's still at the top. Go Chidima. No Pancake GSCE is third place. There are half-term live streams, and you can check out what times they're going to be on the community tab. Okay, for the second game, Kruka Onga is first, Mike is second, and is third. Okay. Chidima's still there. Share her gone up with an answer streak of 3. Diddy Party is first. Kruka Onga is second. Okay. How many questions are there? The first Kahoot, well, in all of the Kahoots there are 50. So not too many because I know this is slightly difficult. Okay. Mike is at the top there. Diddy is second. Mustafa is fourth. We'll do geography paper 2 in one of the lives. So check out the live timetable on the community tab. You'll be able to see it. Unless I haven't put it there. Chidima's at the top. Me has an answer streak of, what was it, 3? Well done. I'll try to, Niati. I will. Thank you for asking. I'll keep that in mind. Okay. Diddy Party's come to the top. Mustafa second. Well done. The first game, Chidima's still at the top. Shehryar is second. George is third. Well done. No Pancake GCSE is falling behind. Come on. No worries. Okay, looking at the scoreboards. Diddy Party first, Mustafa second, Crooker third, Mike fourth, and 1000 there. For the first game, Chidima's still at the top, Shehryar is second, George is third, me is fourth. If you want to join a game, join the Kahoot that's on screen now. And then we'll be starting that really shortly, once that gets a bit more full up. No Pancake GCSE has gone up to 4th place. Let's see if you can get back up to the top. Mustafa's overtaken the second game. Kruka is second. Diddy's gone third. The live stream will probably end after the different Kahoots we'll do. Yeah, at probably 8:30 or something like that. Chidima's still top. Me is second. No Pancake GSCE is third. Look, making your way back up. I see. Mustafa is still at the top here. Okay, I'm going to start this game. If anybody else wants to join, you can still use that link. Okay. Wizard is at the top of the third game. Kruka has overtaken Mustafa, who's second. But Mustafa has a streak of 6 correct answers. Let's see if anyone can beat that. For the first game, Chidima's at the top. 5 players have reached an answer streak of 5. Well done. Waffle GCSE is second in this game. Well done. Okay. On the last couple of questions for the first game. Okay, we're on the last question for the first game. Yeah, Waffle GCSE on top, Jude. Well done. Okay. Now going over the podium for the first game, 3rd place, we have IPv64. Well done. 2nd place, we have me. And first, is Chidima. Well done. You've won so many games in the past. That's amazing. And fourth, you've got No Pancake GSC. And fifth, Zygot. Well done to everybody playing that. We'll do another Kahoot. Give me a second. The live stream's going to end after the Kahoot, so I'm not going to be going over any more content. But we'll be doing some more throughout the week, so just check out the timetable. Okay, we'll do waves. Okay, we'll be doing another Kahoot. So, yeah, 100%. So if you just finished a Kahoot or you want to start another one, this is on waves. So we went through waves today, so you should be able to answer these. This is the code here, the link, or at least. Thank you, Anonymous. See you later. Okay, we're on the last question for this second Kahoot. Mustafa's on top. Let's see if that will change. Well done, Wizard. For the second game, you've got third place, who is I'm Gonna Lose, not really. Second place, you've got Mike. And top, you have Diddy Party. Okay, well done, you guys. Fourth, Mustafa, and fifth, Crooken. Okay, well done. You can join this game here. Well done to everybody who's playing that second round. This next Kahoot is on waves, so you should be able to answer it if you've been paying attention. Okay, and if you are unable to join this live here, join this one instead. But there's still 4 people that can join that. Or not anymore. Okay, join this live instead. And we'll start that game. Okay, you've got Smiley Face at the top here, Wizard second, Waffle GCSE third, Manir fourth, and Dan fifth. Starting the game for the next. All waves transfer. Okay, failing GCSEs is at the top there. GMAC is second, Mustafa is third. Let's see if Mustafa can reclaim his title. Wizard is top for this one. Waffle GCSE is second. Smiley Face is third. That is the Kahoot for that next game. We All Failing is winning. Failing GCSEs is second. Chidima is third. Mustafa is fourth. Waffle GCSE is winning this game. Wizard is second. Smiley Face is third. Munir is fourth. And Dan is fifth. Failing GCSEs is first. Mustafa is rising up second. Chidima is still third. Well done. Just waiting for a couple more people to join that game there. Waffle GCSE is top. Smiley Face is second. Wizard is third. Failing GCSE is first. Happy Snail second. Mustafa third. 100% you should join. These games are so fun. I'll start that game in a couple of minutes. We All Failing is winning. Failing GCSE second. Happy Snail third. Okay, Waffle GCSE, you need to reclaim your position. Come on. Okay. Now that game has become full. So if you're unable to join that game, then join this game here. And we will start this Kahoot. Or, actually, it seems 8 people there. I don't know what's going on. It won't let you join. Please try and rejoin, because there's still only 8 people there. So there's still enough for more people to join. That should be the link. We All Failing at the top still. Wag second. Chidima third. Okay, we're on the last question for this group here. Let's see what that turns out as. Make sure you join that game if you haven't already. If not, we'll just start it because not many people are coming. Okay, now looking at the podium results here. You've got third place, Waffle GCSE. All right, second place, Wizard. And first place, Smiley Face. Okay, nice. Well done to you guys, and well done to fourth place Dan and fifth place Munir and everyone else who was taking part in it as well. So you can join this game here if you want to have a go at another one. It's okay, Jude. Third place is still acceptable. That is for the next game. Okay. For the violin string question, we looked at the key formula. Okay, and looking at the boards here, so you've got softs first, AK second, T third, Manir fourth, and Psych fifth. I don't do history, unfortunately. We are going to be going over case studies for paper 2. Yeah, I think I'll release a video for that soon as well. Hmm. Okay, we'll start this game. If people want to join, they can just join from that recent game pin. You can do case studies you didn't even learn in school. That's why I do videos going through every single one that you need to do. But good question, Mustafa. Okay. Leaderboards here. You've got Love first, Wizard second, Purple Luna third, Rev fourth, and P Wave fifth. Yeah, that's for AQA as well. AK is winning that, Softs is second, Manir is third. These are some difficult questions, actually, so I'm glad that you guys are able to answer them. Okay. You've got Aswa at the top here. We are failing second, failing GCSEs third, Chidima fourth, and Zed fifth. Well done to you guys. AK is still at the top here with the answer streak of 8. Well done. Manir is second, Sofs is third, Issam is fourth, and P is fifth. And here you have Wizard 2.0 first, Ahil second, Purple Luna third, Love underscore Kundi fourth, and P Wave fifth. Okay, we've got the results for this game. So you've got third place, failing GCSEs, second place, Aswa, and first place, We are all failing. Okay. And then fourth, we've got Chidima, and fifth, G underscore Mac. Okay, well done to you guys. We'll just wait for the rest of the other Kahoots to finish. AK is still at the top there. Okay. 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 Wizard 2.0 still winning. And let's see the other game. The other game, you've got AK still at the top, Munir second, Softs third. Thank you, the Green Muslim. I appreciate that. Well done, Ahil, for moving up. AK still at the top here. I love you guys as well. Thank you, Psychedelic. Nice name as well. You guys got some nice channel names. Can we go through magnetism? I was going to end the live here. And we'll go through that the night before the exam. But if maybe watch free science lessons or something like that, if you find that helpful. Or find another time where I'm going through content and we have some extra time, then I might go through that as well. Okay, and the last question for the first team there. Wow, P wave really moved up. Yeah, free science lessons is good as well. Okay, and the results for this group. So you've got third place. Softs, well done. I hope I'm not butchering your name. Second place, Munir. And first place, AK. Well done, you guys. And fourth, SDF. And fifth, Isam. Well done, guys. Just finishing up the last Kahoot game now. The people who already answered this question, they can help you, I guess. Okay. Last couple of questions now. A sound wave has a frequency of 783 Hz and a wavelength of 0.44 meters. Calculate its speed. Okay, answer was 344. First place, you've got Psych. Second, Wizard 2.0. Third, P Wave. Fourth, Love underscore Kundi. And fifth, I. A wave has a frequency of 5 Hz and a wavelength of 0.5 centimeters. Calculate the wave speed divided by the velocity, or wave speed or velocity. Okay, most people got that correct. Second to last question, how do you calculate frequency using a ripple tank? We looked at this. Okay. And your final question for you guys. This is a projection from a ripple tank. What is the wavelength? Is it 2 centimeters, 8 centimeters, 4 centimeters, or 6 centimeters? That will be the last Kahoot, Shaylin. Okay, and looking at the results for this last Kahoot, so third place, we have P Wave, well done. Second place, we have Wizard 2.0. And at the top, we have Psych. Well done, guys. You did amazing. So nice to have you during the half-term live stream. I know there's a lot less people, but I hope you enjoyed it. I hope it made you a bit enjoy revision a bit more than doing it by yourself. So yeah, well done, guys. I'm going to leave you with that then. Thank you so much for joining, everybody. If you have any questions, you can just ask generally. Do you want to do any more? Some of you want to do some more? We can do a really quick one. A general one, okay. Yeah, let's do another one. Sorry for the people who left. I guess they're not going to see this, but let's do a fun one then. Once I made a Kahoot about this channel, but I don't know where that's gone, so I would do that one otherwise. What do you want to do it about, guys? General. What is in general knowledge? Check my emails. Is it because you want to be a mod, Elkie? I do see you in a lot of my, but I haven't got any recent emails. I don't see any. General knowledge. Let's see. I'll try and pick a fun one for us to do. Magnetism. Do you want to do one on mental health? I feel like you guys don't have much of that right now, so there's no point. Yeah, there's some on the Discord server as well, guys. You should watch that. Emails. Am I not getting people's emails? Because look, I could send you a screenshot. I've got nothing in my emails. Literally nothing. I'm sorry, Jude, but I haven't got any. Everyone wants to be a mod. No, not the mental health. Okay. What should we do? What do you guys like? I don't know. I think we'll do general knowledge because you like loads of different things, don't you? Yeah, that is my email. Mods don't get paid. No, they don't. I'm sorry. I don't have that type of funding, guys. I'm barely being paid here, right? I'm not actually being paid at all. But it's fun. That's why I like doing it. Should we do 2024? We'll do a Kahoot, don't worry. Yeah, I'll check my spam. Thank you, Shush. I really can't find any Kahoots to do. K-pop. I never really liked K-pop. Controversial opinion. But I'll do it if you guys like it. Um, yeah, I'm not gonna do K-pop. Okay, music. Music, that's not a bad shout. Oh. Wait, I'll share my screen so you guys can see as well. Oh, you can't see my screen. Have you ever thought of starting up a membership thing on my channel? I might do that. I don't really know how that works, but yeah. Music quiz. What should we do? Okay. Oh no. Actually need to no, that's a bit boring. One sec. Sorry, I'm taking ages. Okay, we're going to do a celebrity one because I think most people know a bit about that. And then we'll do Disney. I love Disney. I love how this is so unrelated to GCSEs, but it's fine. You guys deserve a mini break. Okay, here is the link. I love you guys as well. I hope all of you can fit into that. If you can't, I'll have to do another one. Yeah, what happened to physics? What happened to physics? Okay, it's so dark in my room. Yeah, this is why the lives are the best. Exactly, they're just a vibe. They're realistic, you know what I mean? Thank you, Chidima. You are going to get a 9-9 with this 100%. Okay, that game is getting full, so join this game if you haven't, and if you haven't managed to get into that one, and if not, we'll start this game. Okay, well done. Yeah, I think that you should have breaks because that's what makes studying much more effective. It was Chris Rock, guys. Chris Rock. I shouldn't spoil it actually because some people haven't played this yet. The one who got slapped. I have to check my email again. Let me check my spam. I've got nothing in my spam either. Wait. Let me check the email that you sent. Did you say no waffle GCSE? It's no waffle learning if you said that. My email, nowafflelearning@gmail.com. No, Will Smith slapped someone else. Will Smith slapped Chris Rock for some joke or something. Yeah, it was about his wife or something like that. Okay, we'll start this game too. Red Velvet's at the top, 3 is second, Minnie Mouse is third, Cody is fourth, and Drake's brother is fifth. Yeah, we did do revision. Skip back to the rest of the live. We were doing revision. We've just come to letting you guys chill out a little bit. Oh, guys, this is easy. Yeah, now I've got an email from you, Jude. Now I have. Don't lie, I'm struggling. Guys, I'm actually glad you're performing better in the GCSE quiz compared to this because there's something there. Okay, I'm back going up. Sean Black at the top. I Waffle Bears second, Hee third, Chris Rock fourth. Yeah, you guys do. You're just pros at GCSE. Elkie is making a comeback. You walked into us doing a Kahoot because that's where we've got at this point. That is where we've moved. Forget even trying. We're just going straight into giving up. I understand though because I student once. So studying whole enjoying the Kahoots on the screen. There's still loads of too innocent. She doesn't know any of these. She studies a lot, so don't worry, Chidima. You've won everything else. That's all you need. Look, you guys. I thought you would know all. Or do you know the newer ones? Or do you know the newer ones? Yeah, you guys are actually too academic for me. What am I making you do? The second game. The only celebrity with GCSE. That's guys, you don't know. Expected you to know this. Wow, but it's good. It's really studious and everything. And yeah, they're from when they're younger, which also means that when this happened. There were physics Kahoots, but we've given up on that. And then the people who continued to study just left. But did I see your email? I haven't received any other emails. I think because people think that my email is no waffle GCSE, but it's took no waffle GCSE. So yeah, I've not received any more, unfortunately. Am I lagging? Has it crashed? Oh wow. I'll enter and rejoin. Let me try and fix this. Okay, hopefully that's a little bit better. Thank you for telling me, guys. You are so loyal. Thank you. There's an imposter. That's what I'm saying. Somebody stole my email. I don't know who it is. Why? Why? Yeah. I'm sorry. That's why. Okay, that makes sense. That's why everybody thinks they're emailing me when they're not. Okay, my email is knowful learning, which doesn't help, but Chris Rock is winning that one. Okay, we're in the last question for this group. People are emailing me to become moderators, that's why. Okay, the podium for this Kahoot. You've got third place Minnie Mouse. Well done. Second place Benjamin Mendy. I don't know any of these people. First place Red Velvet. I feel like Chidima should be a moderator. I'm going to give you instant moderator because you've been here through thick and thin and you keep winning everything as well. I can't see fourth and fifth, but well done to everybody. Do you want to do another Kahoot about something random as well, or tell me? I have to Kisten Row Red Velvet. I'm a bit confused about that Z. Okay, last question here as well. No worries, Chidima. To be fair, I should have done it a long time ago. Another one. Okay, you guys want to do another one? What should it be about? What do you want to do it about? Give me some topics. Hawkmaster. I don't know who Hawkmaster is, but thank you. Okay, the results for the final group. Third place, Sean Black. Second, I Waffle Bears. First place, Chris Rock. Okay, well done. And fourth is Smiley Face. Fifth is Hee. Okay. What topic do you want to do it on now? General knowledge. Okay. Okay, there's a lot of general knowledge, but okay. Maths. Did I get the email? Okay, this is a general knowledge one. I'll share you guys. One sec. Here. Thank you, Jude, for sharing my email. What on earth? Oh, okay. I read that so wrong. Okay, this is the last one, and then I'll let you guys go to sleep or whatever you plan on doing. I need to listen to Red Velvet. I don't know what is Red Velvet. Isn't that cake? Check my email. TB wants to be a mod. That's so convincing, TB. TB, you have to do something much more convincing than that. I still haven't received any more emails apart from that, unfortunately. It's a group with good music. Okay. If you didn't join that one, you can join this one here. That's the second game if you are unable to join that. By the way, my email is Noel for Learning. So if you sent it to Noel for GCSE, that's some random person. That's not me. So my email is Noel for Learning. Somebody has taken my email and I don't know done what with it, but Red Velvet is winning. Did you? Well, I just haven't received any emails then. And it's not even in the... Oh, it's in the junk. I found your email. Unfortunately, you have to be in year 11 to be a mod. It's just one of those things. A rule that I've made up right now. Janice is at the top. Okay. If you're unable to join that one, then yeah. You can still join that last game. Are these hard questions? It's supposed to be general knowledge. Oh wow, this is 22 questions long. We'll probably stop closer to that. Okay, I'm going to skip. Janice is at the top. Zed is second. Diddy is third. Mason Greenwood is fourth. Okay. Yeah, subscribe. We need to get to 100k, guys. I'm trying to get to 100k by the end of this year. Mason Greenwood is winning that. Thank you, guys. Thank you. Interesting questions here. What does USB stand for? I've never thought about that. Even I don't know what that stands for. Ooh is winning that one, model. Mason Greenwood answer streak of 6. Well done with your general knowledge. Okay, we'll probably end the live soon. These are weird questions. Okay, we'll end the live soon because I think you guys need to sleep so that you have a nice catch up from probably barely sleeping from your exams. So yeah, I'll end the lives here. Let's see who's won. Let me end it. Okay, for the first one, third place, you have Diddy. Second place, Janice. And first, Mason Greenwood. Well done. I hope that's not your real name that you put on the internet, but probably not. Well done anyway. And for the second game that we did, got third place Griffin, second place Oob, and first place Beazle. Well done, guys. And yeah, let's all chill, go to sleep, have fun, and see you guys tomorrow. So tomorrow's lives will be on, what are they on? Let me check. To check, you can go to the community tab and there'll be the picture there. Tomorrow we'll be doing the whole of GCSE engineering. So I guess it's only for people who are doing GCSE engineering. Oh, Mason Greenwood's a footballer. I didn't know that. Okay, so thank you for watching, thank you for attending. Tomorrow's GCSE engineering, so it's only for people who are doing that, I guess. It might be helpful if you do design technology, but yes. Yeah, engineering is a GCSE. It's literally DT, because I started off doing DT and then I switched to doing engineering. Yeah, I think only some schools do it. But yeah. Okay, I'm going to let you guys go now. Thank you so much for attending the live, and I will see you tomorrow. Or even if you don't do GCSE engineering, please come. I like saying hi to you guys. So yeah, appreciate you. See you later.